like I said, last time we started this, got it set up. I think some of you were kind of like on your way to trying to get it finished. You know, we're all kind of in various stages. So take a few minutes here this morning and either restart it or finish it, or hopefully not, maybe start it. Hopefully you at least started it, right? And I'll be around to help you. We'll kind of try to put it all together in a couple minutes. So I'll draw the picture here. Oh, goodness. So, you know, you drew the picture, something like this. We got the wall, we got the ladder, we got the ground. The ladder's 25 feet. You guys labeled theta. Was that it? Angle between the ladder and the ground. Yeah, so that's theta, and that's x, right? So everybody had that. And I walked around, just about everybody had reached some kind of a conclusion by last time, I think, that the relating equation was cosine of theta equals x over 25. And I believe last time also we had written things down like d theta dt is equal to, that's our unknown, right? Dx dt I think was 2, and it was 2 feet per second, I believe. And the freeze frame moment was when x is 15. And last time you guys had done all the marking of the question. I'm not going to go back and remark it at this point. You've seen it. You've done it. So then what it seemed like today where we were going with this was, I've got all this information. Now we need to push play, get this thing started, come to a conclusion, right? So to push play, we do ddt. So I'm going to do ddt of all of this. One little note I want to make for you is that with this x over 25, I definitely see a quotient rule trap waiting for you. If you think of this as 1/25 x, that might make it a little bit easier for you to differentiate it, realizing it's just a really basic power rule instead of the full-on quotient rule. So I got 1/25 x right there, so when I try to do my derivative, I end up with negative sine of theta times d theta dt, because of course I'm doing ddt of a theta expression, right? And then over here, I'd get 1/25, because the derivative of 1/25 x is just 1/25, right? But since I'm doing ddt of an x term, I'm also going to have that chain rule factor of dx dt. Okay, so you probably recognized at this point that dx dt is 2, and so we could plug that in right now. I can just say, you know, dx dt is 2, so that would just be 2/25 over there on the right. Make sense? Okay, and then, but I still have this whole left side. D theta dt is still there. Negative sine of theta is still there. And you can see now that d theta dt is my objective. It's right there in front of us. The only thing we have to input for is theta, and that's going to have to do with the freeze frame moment. But if you really think about this, the freeze frame moment of 15 does not directly fit with theta, does it? Because theta is an angle. X equals 15 is that base distance. And so you can't just plug the 15 in for theta. That would be a common mistake. Understandable, but still a mistake. So here's what I feel like is the most efficient way of doing this. The bottom line is I want to do sine of theta at the freeze frame moment, right? Once we push pause. So what I'm going to do is I'm going to rewrite the triangle at the freeze frame moment, right? So down below, I'm going to just say, here's my triangle. The ladder is always 25. At the freeze frame moment, the base is 15. This is theta right down here still. And so what I'm supposed to do is find sine of that angle. I think there's a little bit of a trap here where you say, you know what, I want to find that angle and then do the sine of it, and that should work. But instead of trying to find the angle and then do the sine of it, why not just find the other side? If you do the Pythagorean theorem, we find out that it's 20. Why not just find the other side and just do sine of the angle? Does that make sense? Don't worry about what exactly that angle is, whether it be in degrees or radians. Radians would be the choice we want to go with here, but we don't really care what the angle is. We just want to know the sine of it. So let's just skip the whole finding of the angle entirely and just do sine of that angle based on those ratios. Does that make sense? Alex, you having a hard time seeing it? Is that part of the issue? No? Yes? You were kind of... You're okay? Okay, cool. I was just trying to read you. I read you wrong. Okay, so we do sine of that angle. Ends up being 20/25, right? Opposite over hypotenuse. And so I'd come over here and say, well, you know, sine of theta is just 20 over 25. So it'd be negative 20/25 times d theta dt is equal to 2/25. And so to get rid of that negative 20/25, I'm just going to multiply both sides by the reciprocal. So d theta dt is equal to 2/25 times negative 25/20. Of course, the 25s cancel. You end up with negative 2/20, and 2/20 is 0.1. So you end up with negative 0.1. Yes. And units would be? Radians per, is it second? Yeah, radians per second. We do not do the other angle measure. We do radians. So we never went to radians. Okay, so success. I saw a lot of negative 0.1s as I was walking around. So that's great. You don't have to do the whole angle thing the way that I did it. I just feel like that's the fastest way. Did you notice that at no point where I had to turn to the calculator? And thankfully, it was a nice 3, 4, 5 triangle. That helps, right? But at no point did I have to use the calculator to do inverse cosine of this or inverse sine of that. Never had to do that because I tried to deal efficiently with how to deal with the freeze frame. Sorry.
So, are you kind of hinting at this might be a no calculator question?
Oh, a question like this absolutely could be a no calculator question. In no way, shape, or form am I saying that this is on the quiz. I'm not trying to say that. But what I am saying is that I would feel completely justified in asking you this question and saying, nah, no calculator. It's like, at what point did we do crazy decimals? Never. We just dealt efficiently with sine and cosine. Does that make sense? Now, I'm not saying that it would guaranteed not be a calculator question. I'm not saying anything like that. I'm just saying that if I did ask you to do this question and said, yeah, let's not do the calculator, I don't think that I'm asking too much of you. It might stretch you a little bit. It might make you have to think. But it's not asking too much of you. I haven't asked you to do anything that you don't know how to do. It just would stretch you a little bit. And plus, we just did it. Right? I just showed you how to do it. So I think it's even less unreasonable that I would expect you to be able to do this. That make sense? Okay. You're trying to look for hints. I have none for you. I'm sorry. Okay. Any other questions? Anything I can do for you? All right, fantastic. I'm going to do this next one with you guys, and then the last one we will just have you try mostly on your own. We're going to go back to number 3. Yes, number 3, the tank. The tank question. So read this one real quick. This one has its own set of challenges. It's a good one. It says a conical tank with vertex down, 10 feet across the top and 12 feet deep. If the water is flowing into the tank at a rate of 10 cubic feet per minute, find the rate of change of the depth of the water when the water is 8 feet deep. So the first to go around, of course, we just read it and just try to figure out what's going on. Can anybody explain it very briefly in your own words? What is happening? Yeah, water's flowing into a tank. And then, of course, the implication then is that since water is flowing into the tank, and it doesn't say anything about water flowing out of the tank, the water level is rising, right? Okay. So we read it just for meaning at the start there. As we do that, we want to ask ourselves, is a picture appropriate and or helpful? What do you guys think? No, I get a no and a yes, couple of yeses. So since there's at least a couple of yeses, let's do a picture. So it does say conical tank with vertex down. So I'm going to say that might look something like that. Vertex down. Okay. Let's label some stuff here. We are told that the tank itself is 10 feet across. So I'm going to label that. And then we are told that it's 12 feet deep. Well, that didn't go well. Making sense still? Now, we're not told that the tank is full. In fact, I think we can pretty much assume that the tank is not full since water is flowing into it and the water level is rising. Like if it was full, the water level would not be rising, right? It would just be static full, right? So maybe it starts off empty and the water starts to flow into it. So what I'm going to do, again, this is just based on me reading the question and trying to interpret this as a story. I'm going to draw some water in the tank, just a little bit. Oops. I'm going to draw water like this. There's my water in the tank. And it would look something like that. There's my water in the tank. Make sense? It's in there somewhere. So would it be fair to say, of course this is one thing that's unique about water being a liquid, as the water flows into the tank, doesn't the water in the tank form a conical shape as well? Because the water just conforms to the container that it's in. So there's like two little cones in there. There's the big one that's the whole tank, and there's a little cone of water down there at the bottom. Make sense? Okay, so maybe one other thing we could label here would be some labelings on the water itself. Wouldn't it be fair to say that as this tank gets filled up, that cone of water is going to change dimensions, isn't it? So for instance, maybe I could say from here to here, that could be like the height of the water. It's going to change, so I'm going to use a variable, right? Depending on the time, it's going to be deeper or less deep, depending on how long the water's been flowing. And then, I know I have a diameter of 10 up there. I could say that that's the radius of the water. Make sense? The water cone's radius. Okay, so anyway, just trying to draw as detailed of a picture as I can based on my understanding of the situation. All right, so now let's read it again. Let's identify the objective. What do you think this question, is trying to get us to end up with? What should I put a box around? Zach, what was your clue about that? Find. Yeah. Find the rate of change of the depth of the water. So, of course, we're not talking about the tank, right? The tank is pretty much staying the same size and shape, right? But the cone of water is definitely changing size. So find the rate of change of the depth of the water. So based on the way that I labeled it, maybe hopefully you labeled it the same way, what is that as far as the rate variables? Rate of change of depth of water. So rate of change of depth of water is not height. I'm being picky here, but for good reason. dH/dt, it's the rate of change of h, right? So for me just to say that that's h, not really, h stands for height. dH/dt does stand for the rate of change of height. So dH/dt is our objective based on how I label it. If you used x's and y's, then you'd have a slightly different looking objective. But there's that. Okay, other rates that might be important. dV/dt. What are you seeing that's we should underline that indicates that?
Water's flowing into the tank, or at a rate of 10 cubic feet.
Yeah. So water's flowing into the tank, and then of course the word rate is right there. You see that. So rate of 10 cubic feet per minute, and you called that something. You called it dV/dt. Yeah. dV/dt. V standing, I assume, for volume, right? And of course the cubic feet per minute. Yep. You got it. Okay, Ben is on that one. Do you have any questions so far? You see any other rates? Rate of this, coming in, going out, anything? Yeah, I don't see any other rates either. And that's going to be pretty important here in a second. And then, of course, we want to find that freeze frame moment. Freeze frame moment would be, what's the word again? When is the most common word. So when the water is 8 feet deep. So freeze frame moment would be when what is 8? When h is 8. Okay. So let's think this through. We've got a lot of information up there. We've got a cone. We've got a radius. We've got a height. We've got a volume. V's, H's, R's. It's a cone. We want to try to put these things together, right? Into something that relates it all together. This should always come from something in your past, something you studied in Algebra 1 or Algebra 2 or geometry or whatever, and sometimes it'll just be given to you, right? Like the car question. It's not given to us here. Sometimes it will be. What do you think? What relates all this? Yeah. It is the volume equation for a cone. Does that make sense? V stands for volume. You've got R's and H's and all these things. And the next question would be, do you know that? That's really close. It's 1/3. Yeah, 1/3. So volume formula, equals 1/3 pi r squared h. Johnny was looking for hints and little signs of what maybe to come or something. Let me just come right out and say this. That's not a formula that I would expect you just to pull out of your math library in your brain. If I did give you some question like this, I would probably give you all of the formulas for a cone. I'd give you like the surface area, the volume, any other relationships having to do with the cone, and you'd have to just pick the one that makes the most sense. That makes sense? So I'm not going to just like tell you, or maybe I will, but if I don't, I would give you like a library for these. I would expect you to know the area of a square, the area of a circle. We use that stuff a lot, right? I would expect you to know the area of a triangle, things of that nature. But we start to get into these three-dimensional shapes that we use a little bit less. I'm not going to just assume that you have this just down, so especially if it's out of the blue. But anyways, you've identified the right concept without a doubt. So 1/3 pi r squared h. So here is where we're going to have to think a little bit. We know, I think we know, what would we do next? Once we've identified this?
DDT.
We do DDT, right? We'd push play. I want you to think about something, though, before we push play. So like this would be, I don't know, maybe I'm taking my analogy a little bit too thin here. But, I hope that you are conscientious of the types of things that you allow into your brain, movies and media being one of them. So, maybe you picked out this movie and you're like going to push play and it says, rated R due to the following elements in the movie or something. You're about to push play and you see that little rated R thing and you're like, ooh, caution, right? There might be some objective things in here that, listen, honestly, don't be dumb. Garbage in, garbage out. You watch enough stuff, it's going to come out. That's just, if you live long enough, you'll figure that out eventually, if you haven't already figured that out. And so there's a little caution here, right? Let me explain the caution. We know that we're about to push play and do DDT. So let's think this through. If I were to push play, would I not get a DVDT in there somewhere? That's going to show up, right? Is DVDT, is that okay with you? It better be, because we've got it right there, 10, we know all about that, right? We're okay with 10 cubic feet per minute. Yeah? Okay. If I did DDT, well, 1/3 in pi, those are just constant multiples, and so those will be in there somewhere, but those are no big deal. If I did DDT, wouldn't I get a DRDT? There's your caution. We don't really want that to be part of our problem. Why don't we want DRDT to be part of our problem? We don't know what it is, and it's also not our objective. That make sense? So DRDT is like one of those unknown things, like if you were at a party and somebody's like, here, try this, and you're like, what is it? And they're like, try it and find out, or some really stupid comment like that. You don't know what it is, don't do it. That makes sense? So DRDT, we don't know what that is, and so we need to actually take another little step back here and say, maybe we should get the tamer version of this movie, right? Maybe we should get the edited for TV version of this movie or something like that. We want to get rid of the R is what I'm trying to say. R-rated, R, just kind of coincidental. Anyway, this is the supreme challenge of this question. I don't know if it's going to be that hard for you. If we can navigate this, it's going to be pretty quick and easy to finish. So, can you see any other? We need to come up with another relationship that's going to allow us to ditch the R and replace it with something that we either know about or want. What do you see, Jackson?
Is it similar triangles?
Totally. You just navigated right through that. If you look at cones, don't we have a big cone and a little cone? If you look at a cone as a two-dimensional figure, they really are like triangles, aren't they? Okay, so Jackson, you came up with the right idea here. Let's see if you can execute it. What similar triangle concept would you try to use here to do what we need to do?
Oh, okay. 10 over 12 equals x over 8.
10
Or r over 8.
over 12 equals r over 8. Okay, so...
Wait, no, that's wrong.
Okay.
Failed.
Well, let's... If you notice you did something wrong, let's fix it.
2r over 8. Or you can half the other second.
Okay, so 5/12 or 2r. Can I go with 5/12? Okay, I'd rather just make something simpler than a little more complicated. Okay, so 5 over 12 equals r over 8. What do you guys think about that?
Can you plug in the freeze frame that earlier?
There's the issue. You've really come very close. You have the exact right idea. The only problem is when you say 5 over 12, you're saying that the tank always has the top radius is always 12. Is the top of the tank always a radius of 5? Yeah, the top has a diameter of 10, so the top of the tank always has a radius of 5. Is the height of the tank always 12?
Yes.
Yes, I got no problem with the left side. Left side is right on the money. On the right side, he's saying, hey, R will vary. And as the tank fills up, won't that cone of water have a bigger and bigger radius?
Yes.
Okay. Sure, as the tank fills up, bigger and bigger radius of the cone of water, but is the depth of the water, the H, is that always 8?
No.
It's not. So instead of 8, I should put H. And this will actually help us really
Substitute.
get this substituted out. That's the right word. So if I put 5 over 12 equals R over H. Jackson, that might be a record on seeing the relationship, to be honest, like a record for speed. Like you were like, similar triangles. That's pretty impressive. We just had to tweak the one little thing on the right. So really good thinking, really good thinking. Okay, so I got 5 over 12 equals R over H. And what is it that I want to get rid of? R. So if I solve for R in the second equation, that'll allow me to actually substitute. So I'm going to write 5/12 H equals R. So now what I can do is I can go pick the edited for TV version of this movie by replacing the R with 5/12 H. So V equals 1/3 pi times 5/12 H squared, quantity squared, times H. And we're much happier with that movie because now when we push play, the only things that are really going to show up would be dV/dt and dH/dt. dH/dt we are trying to find, and dV/dt we already know. Yes, sir. We'll simplify it. Yeah, we definitely want to simplify this for sure. So if I do simplify it, let's see here. Volume equals, it would be, 25. And then 12 squared is 144. You know what? Can I just do this? I just saw something that will make this easier. And then it would be pi h cubed. It's just 12 squared is 144. Did anybody see why I wrote it the way I did? What am I going to do in the very next step?
The 3's will cancel.
Yeah, the 3's are going to cancel when I differentiate.
Oh.
So you don't have to do it that way. It's just something I saw, so I left it like that. If you did it the other way, obviously it's no big deal. Okay, so that right there, that's really the movie we want to watch. We don't want to watch that other junk. We want to watch that one. So now we finally say, hey, cool, let's push play, and we can finish this out. Do you see why that's the real challenge of this question? Getting it substituted and getting the objective elements removed. That's really the hard part. Okay, so let's run through the other steps here. To push play, that's really doing what? ddt. So ddt of v would just be dv dt. And then that whole right side, let's be honest, I've got a really big, nasty-looking constant multiple, right? It's 25 over 3 times 144 pi. That whole thing is just a constant multiple. So when I differentiate, it's going to be 3 times 25 over 3 times 144 times pi times h squared, and then times the chain rule factor of dH dt. The 3's will cancel. Still haven't picked up my calculator. Just because we don't have to. Keeping it easy, right? And now I think we can plug stuff in. Maybe we turn to the calculator at this point. That'd probably be nice. So let's see here. dV dt we know from before is 10. So I'll put 10 right there. I've got 25 144ths pi. And then h, that's the freeze frame moment. H is 8, so 8 squared. And then dH dt is my unknown. So let's use the calculator. We got that pi in there. So we could write this in terms of pi, but let's take the easy button this time. 10 divided by that whole mess. Let's figure it out. Bianca, did you get an answer?
I think so, but
Would you mind sharing?
I don't think it's right because
Oh my gosh. You should still be working if you don't think it's right.
I solved it a different way.
You say it again?
I solved this a different way than
What'd you get? It's okay. Just tell me. I won't write it up there.
8.48.
Say again? 8.48. Okay. I honestly don't know what the answer is. What'd you get? 0.286. You got 0.286? Bianca, I'd be curious to see what different method you used, because they're all saying yes. Did you guys get 0.286 approximately? Okay. So 0.286. What units would go with that 0.286? It would be feet per minute. Yep. You can tell that from the Leibniz variable. H is measured in feet, T is measured in minutes. So, yeah, 0.286 feet per minute would be dH dt. We all agree? We are all good? All right, good deal. We're going to finish things up here in just a second. Before we do, though, any questions? Okay. So I gave you a graph. It says find the rate of change between the function, y equals x cubed, blah, 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 and y equals sine of x squared if dx dt is equal to 2 when x equals 1. So I drew the graph out there for you. I thought I'd draw the graph just so I could illustrate a little bit too. How would we illustrate the distance between those two graphs? Like what would it look like if I tried to draw in a representative of the distance? How would I do that? It's really important as far as getting this thing set up, understanding like what's happening from a picture standpoint. Okay, nobody wants to talk. Would this be a wise representation of the distance between them?
No.
Oh, why not? What's implied here? Say again? Sorry, say again?
They're changing x values.
Totally different x values on each end of the distance. Okay. Zach, you said
It has to be between like the value or the two like closest points like at that value.
oh, the two closest points at that value. So what kind of a line should I have drawn? Well, that's a straight line, or I tried at least. It should be a vertical line. Yeah, that's right. So vertical line. So this would be an example of the distance, another example. And of course, our freeze frame moment is right there when x is 1. I did kind of jump up on the freeze frame moment there. Of course, that's the word when. Okay. So let's run through this first part real quick, and I'll let you guys finish it. We've read it through. We see there's a picture. We illustrated the picture a little bit. What's the objective?
Find the rate of change in distance.
This time it's the first sentence. A lot of times it's like in the middle or the end. This time it's the very first sentence. So just be aware it could be at any spot. So find the rate of change of distance between the functions. How do you want to interpret that as far as those rate variables go? You could do dd, maybe a capital D for the distance. So I'll say dd, dt. That's our objective. Any other rates that you see we could underline and like set aside for later use? What do you see, Lainey?
Well, is it dx over dt equals 2?
Yeah, dx dt by nature is a rate, right? Yeah, so that's exactly what we're going to use. And you can recopy it, I suppose, if you want over here. Dx dt is equal to 2. It doesn't give us units here, like units per minute or something like that, but that's okay. And then the freeze frame moment we already pointed out is x equals 1. So I want to leave you with this before I let you try to finish this off. What's the relating equation? I've got distances, I've got x's, I've got some functions, I've got a picture of the graphs of the functions. What relates all these things together? Set them equal to each other. You subtract. Any other ideas? Well, let's at least analyze those two ideas. Josiah jumped in and said set them equal to each other. So Josiah, I assume when you say set them equal to each other, you're saying set the cubic equal to the sine function, right? Am I right that that's what you were intending? Yeah. Okay. So think about what that's going to accomplish. Is that going to accomplish what we want, or do we need to think about what Ben said? Because he said it second. What do you think, Matt? Why? What's wrong with Josiah's way? Right. So if we set them equal to each other, isn't that finding an intersection point? And we don't know exactly what happens to the left or the right of this picture, but at least in this area, we can see that they actually don't intersect. So I don't think we want to look for an intersection point. Ben, you said subtract. Subtract what? Sorry?
X cubed minus the sin x squared?
So high minus low?
Yeah.
Because you guys can see the red function is the sine, right?
Right.
The blue one is the cubic. Ben's got it. Ben's got it. That's what we want to do. So to find the distance between two things, you simply subtract their positions. And so that's going to be our relating equation. So I'll write that out here. Distance between them equals the cubic minus that sine of x squared function. There we go. And that's in a pretty good place. Let's see here. Is this going to end up being like have some objective elements in there? Like if I do ddt, will I get some bad stuff like I did with the cone? I'd get a ddt, right? That's what I want. I'd get a dx dt. I know what that is. Anything else? I think we're in the clear, right? Let's push play and let's roll. So a few minutes to go here. You probably have just enough time to finish this up. Give it a shot. So you can see we're in a good place. We've finished everything. Monday we'll review. We can come back to this one if you want. And as you know, you've got a ton of other opportunities as far as practice goes. Bring those with you on Monday, and I feel like we'll be able to be very productive. Get you into the best possible place before we go. I'm going to work quietly up here. Feel free to look. If you've already done your DDT, maybe check out what I've done, see if you like it or agree with it or disagree with it.
You factored it out. That
Yeah.
makes sense.
I recognize that every single term would have a dx dt in it, so I just automatically factored it out. I didn't want to write it 1, 2, 3, 4. I didn't want to write it 4 times. I figured, let's just write it once outside of parentheses. That's not always going to work, but in this case, I think it does. Once you've done that, you know what dx dt is, you know what the freeze frame moment is. Make sure you're in radian mode, because if you're not, you're going to get the wrong answer. Anybody have a answer for that one? What'd you get?
50.16. Is that right?
I have no idea.
That is good.
I'm sorry. So it's a number, so we're at least talking about the right kind of thing, right?
There you go.
I do not pre-rehearse these, so I don't know. I don't. So maybe it's not 50.161. What are you guys coming up with? 21.838 or 839. Okay, so 21.839. Are we getting more agreement on that? Yes? You think that's it now?
I swapped the sign.
Okay, it happens. Absolutely happens. You guys agree with that now? That number? Okay. And then as far as units go, this is kind of like unitless. It'd be something distance per time. I don't know, units per time. You don't really have to put, if you don't get units, you don't have to put them. So let's not worry about it. Please don't make any up. We'll just leave it like that. So, guys, wonderful job. You got some